Hey, hi everyone, welcome back to this video series on Windows Server 2016, flushing the ARP cache. Earlier, we had a little discussion about how switches keep a cache of ARP information, which lessens the time those switches need to take when deciding where packets should flow. When you assign an NIC and IP address, the MAC address of that NIC gets associated with the IP address inside the ARP table of certain pieces of networking equipment, switches, routers, firewalls. These tools commonly have what we refer to as an ARP table, and therefore they have a set of data in that table that is known as ARP cache. When configuring NLB, particularly unicast, the NIC's MAC address gets replaced with a new virtual MAC address. Sometimes the switches and networking equipment are very quick to catch on to this change, and they associate the new MAC address with the new IP address, and everything works just fine. However, I find that when configuring NLB, the following is generally true. The smarter and more expensive your networking equipment is, the dumber it gets when configuring NLB. What I mean by that is your networking equipment might continue to hold on to the old MAC address information that is stored in its ARP table and doesn't get updated to reflect the new MAC addressing. What does this look like in real life? Network traffic will stop flowing to or from those NICs sometimes when you establish NLB and it turns itself on. All network traffic will suddenly stop cold to or from those network interfaces. What do you need to do to fix this situation? Sometimes you can wait it out within a few minutes, hours, or sometimes a few days. The switches will drop the old ARP info and allow the new MACs to register themselves in there. Okay, what can you do to speed up the process? Flush the ARP cache. The procedure for doing this will be different depending on what kind of networking equipment you are working on, whether it is a switch or a router, what brand it is, what model it is, and so on. But each of these guys should have this capability, and it should be named something along the lines of flushing the ARP cache. When you run this function of your equipment, it cleans out that ARP table, getting rid of the old information that is causing your problems and allowing the new MAC address to register themselves appropriately into the fresh table. I only wanted to point this out in the event that you configure NLB only to see traffic flow cease on your server. More than likely, you're dealing with ARP cache being stuck on one or more pieces of networking equipment that is trying to shuttle the traffic to and from your server. Failover clustering. We have established that network load balancing is a great solution for stateless applications, with a prime example being websites that you want to make highly available. What about other server roles or functions that you want to make redundant? Well, the opposite of stateless is stateful. So how about giving high availability to stateful pieces of technology? Failover clustering provides this level of capability and can be used in cases where the nodes within the cluster are accessing shared data. This is a key factor to the way failover clustering is designed. The storage used by the cluster nodes must be shared and accessible by each node that needs it. There are many different roles and services that can take advantage of failover clustering, but there are a solid 4 specific technologies that seem to make up the majority of clusters running in data centers today. Hyper-V, file services, Exchange, and SQL. If you're working with any of these technologies, and the chances are you work with all of them, you need to look into the high availability capabilities that can be provided for your infrastructure by use of failover clustering. Why failover clustering provided by Windows Server is Microsoft built and has the capacity to work very well out of the box with many Microsoft roles and services. It is important to note that you can establish failover clustering for non-Microsoft applications as well. Third-party applications that run on Windows servers in your environment, or even homegrown applications that have been built in-house, can also take advantage of failover clustering as long as that application uses shared storage and you can specify the tasks that it needs to be able to perform against those applications for the clustering administration tools, how to start the service, how to stop the service, how to monitor the service health, and so on. You can interface these custom services applications with failover clustering and provide some major redundancy for just about any type of application. Clustering Hyper-V hosts. One of the most powerful examples of failover clustering is displayed when combining clustering with Hyper-V. It is possible to build out 2 or more Hyper-V servers, cluster them together, and give them the capability to each host all of the virtual machines that are stored in that virtual environment. By giving all of the Hyper-V host servers access to the same shared storage where the virtual hard disks are stored and configuring failover clustering between the nodes, you can create an incredibly powerful and redundant virtualization solution for your company. When a Hyper-V server goes down, the VMs that were running on that Hyper-V host will fail over to another Hyper-V host server and spin themselves up there instead. After minimal service interruption while the VMs spin up, everything is back online automatically without any administrative input. Even better, how about when you need to patch or otherwise take a Hyper-V host server offline for maintenance, you can easily force the VMs to run on a different member server in the cluster. They are live migrated over to that server so that there is zero downtime, and then you are free to remove the node for maintenance and finish working on it at leisure before reintroducing it to the cluster. We use virtual machines and servers for all kinds of workloads. Wouldn't it be great if you could rid yourself of any single points of failure within that virtualization environment? That is exactly what failover clustering can provide. Scale out file server. Clustering for file servers has been available for quite a while, but was originally only useful for document and traditional file utilization. In other words, information that remained static and unchanged for much of its life. With the onset of virtual machines, and now that we can make use of clustering to enhance our Hyper-V infrastructure, what is the best way to store those shared virtual hard disk files? It makes sense that you could also take advantage of failover clustering on your file servers in order to enable this highly available shared network storage that all of the Hyper-V hosts could access, and you would be right. While the original version of file server failover clustering was not comprehensive enough to handle files that were continuously open or being changed, like virtual hard disk files, scale out file server SOFS is designed to do exactly that. If you plan to host virtual machines, using Hyper-V, you will definitely want to check out the failover clustering capabilities that are available to use with Hyper-V services. Furthermore, if you intend to use clustered Hyper-V hosts, then you will definitely want to check out scale out file server as an infrastructure technology to support that highly available Hyper-V environment. Scale out file server helps support failover clustering by providing file servers with the capability to have multiple nodes online that remain persistent between each other constantly. This way, if one storage server goes down, the others are immediately available to pick up the slack without a cut over process that involves downtime. This is important when looking at the difference between storing static data such as documents and storing virtual hard disk files being accessed over the VMs. The VMs are able to stay online during a file server outage with scale out file server, which is pretty incredible. Clustering tiers. An overhead concept to failover clustering that is important to understand is the different tiers at which clustering can benefit you. There are two different levels upon which you can use clustering. You can take an either or approach and use just one of these levels of failover clustering. Application layer clustering. Clustering at the application level typically involves installing failover clustering onto virtual machines. Using VMs is not a hard requirement, but it is the most common installation path. You can mix and match virtual machines with physical servers in a clustering environment, as long as each server meets the installation criterion. This application mode of clustering is useful when you have a particular service or role running within the operating system that you want to make redundant. Think of it as more of a micro clustering capacity, where you are really digging in and making one specific component of the operating system redundant with another server node that is capable of picking up slack in the event that your primary server goes down. Host layer clustering. If application clustering is micro, then clustering at the host layer is more macro. The best example I can give of this is the one that gets most administered with failover clustering in the first place. Hyper-V. Let's say you have two physical servers that are both hosting virtual machines in your environment. You want to cluster those servers together so that all of the VMs being hosted upon these Hyper-V servers are able to be redundant between the two physical servers. If a whole Hyper-V server goes down, the second one is able to spin up the VMs that have been running on the primary node. And after a minimum interruption of service, your VMs, which are hosting the actual services, are back up and running, available for users and their applications to tap into. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.